We are collecting unexpected news from deep space. Just as geologists dig deeper underground to find ever more ancient fossils bearing witness to ever more remote epochs, so astronomers excavate deeper and deeper towards the beginning of time by looking for light coming from fainter and thus more distant objects. Hubble started a new era we could call astroarchaeology, and it began during Christmas 1995. Pointing the world's most sophisticated telescope at the same piece of sky for 10 days in a row may sound a bit strange. And this was what many astronomers thought when they tried it for the first time at the end of 1995.
Deep field observations are long-lasting exposures pointing at a particular region of the sky. They aim to reveal faint objects by collecting as much light as possible over a long period of time. The deeper an observation goes, the fainter are the objects that become visible. Objects in the sky can appear faint either because their intrinsic brightness is low or because their distance is great.
When this experiment was first proposed, an experiment consisting of staring at the same patch of the sky for weeks, nobody really knew whether it would have led to interesting scientific results. But when we first saw the images, the result was astonishing. We could see more than 3,000 galaxies in this small field.
The observed region of sky in Ursa Major, the Big Dipper, was carefully selected to be as empty as possible, so that Hubble would look far beyond the stars of our own Milky Way and out past nearby galaxies. The thousands of galaxies observed in the first deep field were at various stages of evolution and were strung out along a corridor of billions of light years. This allowed astronomers to study the evolution of these objects through time, glimpsing different galaxies at different stages of their lives. After the first deep field, another long exposure was taken in the southern sky. Together, the Hubble Deep Field North and South gave astronomers peepholes to the ancient universe for the first time. Some of the objects viewed on the images were so dim that seeing them would be as difficult as discerning a flashlight on the moon from Earth.
And we could definitely tell that the Hubble Deep Field has opened a new era in observational cosmology, transforming our view of the distant universe.
The Hubble Deep Fields have caused a real revolution in modern astronomy. After the first deep field, almost all ground and space-based telescopes were pointed at the same area for long periods. Some of the most interesting results in astronomy have emerged from this fruitful synergy between instruments of different sizes, in different environments, and with sensitivity to different wavelengths. They gave us the first clear picture of the star formation history throughout the universe. Astonishingly, they showed that star formation peaked within the first few billion years of the universe's creation. At that time, stars were forming at over 10 times the rate they are today.
Once they had begun to discover the most distant universe ever seen, Hubble astronomers tried to push their observations even farther back in time. In 2003 and 2004, Hubble performed its deepest exposure ever, the Hubble Ultra Deep Field. It is a 28-day-long exposure, going much deeper than the earlier Hubble Deep Fields North and South.
The Hubble Ultra Deep Field reveals the first galaxies to emerge from the so-called Dark Ages, the time shortly after the Big Bang when the first stars reheated the cold, dark universe.
Just after the Big Bang, in the newborn, fast-expanding universe, before the era of the stars and galaxies, the distribution of matter was fairly smooth. As time went on, the king of all forces, gravity, started acting. Slowly, but steadily. Under the influence of gravity from the mysterious dark matter, small clumps of normal matter started to coalesce in regions where the density was slightly higher than average. With no stars to light up space, the universe was in its dark age. Where the density of the clumps became higher, even more matter was attracted, and a competition between the expansion of space and gravity took place. Where gravity won, regions stopped expanding and started to collapse in on themselves. The first stars and galaxies were born. Where the matter density was highest, at the intersections between the large web-like structures of matter, the largest structures we know were formed, clusters of galaxies. The deep field images are